All right, today we're talking about weathering, erosion, and sedimentation for Unit 2. So, yes, that's me. Pictures of me right in there. It's pretty cool. I'll tell you what it's all about. Okay, so you may have learned some of these terms in middle school. That's fine, but we're going to apply them to AICE marine science at a higher level, right? Okay, so weathering, simply put, it's breaking down. Weathering is breaking down rocks and sediment, producing smaller fragments. That's it. But the biggest problem here with these words is that students tend to mix them up. A lot of people say erosion is everything, but it's not. Erosion is only one part of it. Erosion is moving that sediment from point A to point B, okay? So it's moving it away after it's weathered. So erosion and weathering are different. And here you see you've got this material's already been weathered. The waves will come in and they'll move the sand away, which is erosion. Here, this is actually in Blowing Rocks Preserve in Jupiter, last year, a year ago, and it's really cool. Most people wouldn't think that we have a rocky shore in Florida. Rocky shore, you think, oh, California, Washington State, Oregon, Maine, the North Shore of Long Island, New York, and up there. No, we have some down here as well. There's none on the West Coast as far as I understand, but there are a couple of outcroppings right here in, just a few minutes away from Boca. So, and this is called Blowing Rocks because when the tide comes in, water will shoot out of this, and there's many of these tubes. It's called a tube, and it'll shoot out into the air. It's pretty cool. Look like a blowing rock. And so this is limestone that was laid down by, corals and other creatures millions of years ago, and it's been exposed. So. And you can crawl on them and you can walk around them, and it's amazing. It's a really, really neat place to go. Blowing Rocks Preserve. And those rocks have been eroded and weathered. So the waves are beating on them, knocking small pieces off, weathering them, and then the waves or wind carry the sediment away. That's erosion, okay? And there's two different kinds of weathering. Weathering can be chemical or physical, okay? They're called pipes, yeah. So intense combination of chemical and mechanical weathering. Mechanical weathering is also called physical weathering. And chemical is when it's broken down, when the rock is broken down with chemicals. Typically, the only chemical that occurs in nature is acid. So acidic water will break down shells, rocks, coral exoskeletons. When you've ever been to a cave or ever seen a cave anywhere, it's that carbonic acid that we had on a bell work a week or so ago. That's a very weak acid, but over time, over thousands upon thousands of years, it's slowly taking off layer by layer, molecule by molecule of that limestone, eating it away, and reintroducing that calcium back into the environment for animals to use it again. And that's chemical. Physical is like breaking, like you took a hammer and you hit it on the rock, it would break, and that would be physical weathering or mechanical weathering. Also sand. I took this picture because the sand, due to the motion of the waves, is constantly rubbing like sandpaper on these rocks, on this old limestone, and slowly abrading it. That's what abrasive means, breaking it down. Organic weathering. This is not something you're going to learn in a physical science class. This is a marine science class, and I love this animation because it's also called biological, also known as biological weathering. Burrowing animals that will eat through rocks, okay, and coral predators like this parrotfish. Parrotfish will eat the coral, and no joke, poop out sand, white sand. It eats the coral, and the coral has living tissue over the top. It's an animal, so it eats the coral, but it also takes a few bites of the coral's skeleton beneath, and it can't digest that because it's literally sand. So it just poops it out, and it makes white sand out of it. It's just incredible how all these different animals and organisms interact. All right, so we've got the interaction between of erosion with ice, water, wind, and gravity. So erosion can occur by ice because glaciers, like this time lapse, this is over like weeks, okay? The glacier is slowly moving through, it essentially rides on a very thin layer of water, meltwater at the base. And it slowly moves through this valley, cutting it out. Glaciers cut out in U-shaped valleys. So if you ever see a U-shaped valley somewhere in the mountains, a glacier did that. A V-shaped valley is a river. V is a river, U is a glacier. And it takes that sediment that it picks up and scrapes off and carries it away. So the ice is weathering the rock, and at the same time it's moving it, it's eroding it. A fjord is very popular locations in Scandinavia, and those big mountains on both sides and water down below. Those were carved out by glaciers. Fjord, that's how you pronounce that. So I'm from Long Island, okay, I'm from right there. The green X right there, okay, that's New York. So most people think New York is just like the city, but it's this huge state, and then it's Long Island that comes out here. So this is the city there, and if you're anywhere from this line, this is Queens. So if you're anywhere east of Queens, you are a Long Islander, okay? And that's me. So Long Island came formed because of this, right? So the glaciers came down in the last ice age. They came down and they were scraping all of this debris from the ground, from the earth, and then carrying it down this way. Then when they melted, they deposited the debris that they were carrying, and that's called deposition. So it's weathering, erosion, deposition. The word spelled is wed, like to have wed somebody in a marriage, right? Wed. So it spells a word. Any other way, I guess backwards it could spell do, but then it's really bad if you're doing it backwards. I guess if you're mixing up EWD, that doesn't really spell anything. So wed, okay? Remember wed. That's how you remember the order. So weathering first, then erosion, then deposition. So the glacier drops off. And so Long Island was essentially dropped off. Glaciers came down, this was underwater, and then when the glaciers receded, it made Long Island. And you could see big giant boulders and stuff on Long Island. It's pretty cool. So water can erode things, obviously. So rivers, waves, currents, tides, they'll carry that sediment someplace else. Wind, of course, can transport sediment very great distances. If you've ever been at the beach on a windy day, wind picks up and you start to get like sandblasted on your legs and your face, and you have to cover your eyes and run back up shore, you've experienced that sediment being carried great distances, okay? We're in Florida, duh. But if you look at a map of the world, or a globe, which I have right here, you can see that Florida is directly across the ocean from Africa and the Sahara Desert, okay? So sometimes the winds are just right that great dust clouds move across the ocean and come to Florida. We just had some a few weeks ago here, and it doesn't really affect us particularly, but it makes for beautiful sunrises, okay, because the sun has to be filtered through all that dust in the air, and that's erosion. That's sediment, very fine sediment, moving across the world. As a matter of fact, the Amazon rainforest is given nutrients by the Sahara dust storms blowing over the Atlantic Ocean. That's just amazing. So you can tell, 100 million years from now how that's going to change, because the distance of the Atlantic is growing, and because of seafloor spreading, right? And so that dust is going to have a lot more time, it's going to have a lot more distance to cover, and so the Amazon won't be getting the nutrients it needs. So the Amazon will probably change to something other, different environment, well before 100 million years. But anyway, so gravity is another one. Gravity obviously is going to move rocks. If I put a rock on a hill, it's going to roll down. Gravity's now the main player in that erosive process. And it happens underwater too. This is an underwater landslide, and that will actually create a tsunami. So if you look up the Azores, there was a volcano there recently. If that volcano has a landslide into the ocean, it will make a huge tsunami that will destroy the east coast of Florida. Chances of it happening are very slim, but still good to know. So here's wind blowing across the dry sand. So some of you may have experienced this before, but it doesn't feel good. You want to run, or at least have pants on. All right, so here's some more landslides. Here's some more gravity taking over. So it's amazing when they catch these on camera, but the whole mountain fell off there. And here's people at a beach, and the entire it's not a very good video, I know, but this entire rock slab falls off into the water, and it makes this big wave come up onto the beach. So people are running for their lives. That's the earth. That's what it does. You're going to play next to it. You better watch out for it. Whenever I see these people sitting on the edge of a cliff, we've got this piece of rock hanging over the cliff, and there's this little person dangling their feet over the edge. That's pretty stupid, because maybe it's that moment that just their 150 pounds of weight is going to make the rock fall off, and they're going to fall to their death. So don't play around if you don't have to. This is really wild. This whole part, this was in somewhere in Scandinavia, Denmark or something like that. I don't remember exactly, but this just happened not that long ago. And there's video of it, video that occurred not at the beginning, but towards the end. Anyway, this whole piece of land just decided it wanted to, look at this place, just sitting here. It looked, if you delete all this just looks totally normal. It just decided gravity was going to pull it all down in the water. And all these houses and structures that were on this beautiful shoreline were just gone into the ocean. This was March 8th in LA County, California, March 19th, May 31st. So this was a landslide. This is the Pacific Highway. I don't know if you've ever been on the Pacific Highway in California, but it decided that it's time to move, and the entire hillside just went down into the ocean. So that is erosion, okay, and deposition all together. So we're on deposition now, yes, okay, so sedimentation. Sedimentation is deposition leading to a buildup or an accumulation of sediment. Anybody ever been to a sandbar before? It's very popular to have sandbar parties where you pull up your boat, get out, everyone's hanging out in the water, having fun, looking for seashells and whatever, and listening to music. Hopefully not too loud, disturbing your neighbors. But don't be one of those kind of people. So here's a deep sea fan. So this is the shelf, and this is the abyssal plain. We talked about that in the last set of notes. Sometimes you get a landslide underwater, which we talked about before, and it makes this deep sea fan. Okay, so that's sedimentation. It deposits and builds up. This is a river delta where the fresh water is coming out here into the salt water, and the river is depositing, and this is what's being estuary, right? Where fresh water and salt water mix. That's in this unit. It's one of your words you made a vocab card on. So fresh water is coming in, carrying silt and other, particles, and then it deposits it here, and it's called either an alluvial fan or a river delta. So here you've got some more these waves. The wave action is pushing sand to make these, they're called sand spits, like spit, like that, okay? It's called a sand spit, and people love them because they're fun places to hang out. But they're important for movement of tides and transporting of material. So, particle size is a big point we have to make here. Depending upon the particle size, the particle is going to move less or more, right? Bigger particles are going to move less, and smaller particles are going to move faster. The bigger particles are going to need more energy, and the little particles are going to need less energy, okay? Here's an example on the north shore of Long Island, I believe, although I'm not 100% sure. Anyway, south shore is all sandy, and the north shore is all rocky because the glaciers had a harder time getting rocks to that side of Long Island. They dumped them all at the north side. They fell first. And then the lighter material, because it's easier to move, they're smaller particles, they got pushed farther. They moved farther as the meltwater carried the glacier away. So you can see here, this is very clear. Also, this cliff is eroding, right? Weathering, and then eroding, and then depositing. The bigger particles get deposited farther, closer to the wall, and the smaller rocks and smaller particles get deposited farther away. So on the coast, the smaller particles will be at low tide zone, and the larger particles will be higher up. The faster the movement of water, the more energy, so the more larger particle can move. And this is a size comparison of these particle types. So you've got clay, which is very fine, okay? And then that's why when you have clay soil, water doesn't penetrate it very well because the particles are so tight together. Silt is a little bit bigger, and then sand compared to that is much bigger, okay? It's kind of like the sun, Jupiter, and the Earth. That's a very good way to compare them. So the more energy, the larger the particles it can move. Oh, the littoral zone. So here's me walking in the littoral zone at Blowing Rocks. So the first pictures you saw were down here on these larger rocks. And then all of these rocks go all the way through the whole thing. And it's very dangerous to walk in because there are huge holes. And if you're out here, you can't really see them because the waves are coming in and you can get really hurt. So, but it was fun. It's a really fun place to go and explore. And you get to see so many, the creatures, the animals here that are found nowhere else in Florida. You would have to go very far away to find some of the animals here because they only live on rocks. They only live on rocks. So, so the littoral zone, simply put, you guys should have made a card for this. And for one of the classes, I drew it on the board, but it's the zone between the highest high mark and the lowest low mark on the beach, on the shore of any shore, a sandy shore, a rocky shore, an estuary, it doesn't matter, okay? So this is all littoral zone. This is somewhere in Boca, I think, and that, of course, is the littoral zone. So the littoral zone is right there, from the lowest low to the highest high. And notice how terrestrial plants are not in the littoral zone, and then the photic zone of the ocean is going to be near that area and below, And then even deeper, aphotic means no light. It's not a very good depiction because it looks like there's light there, but anyway. So you need to know the difference between the shores when you see pictures, okay? So here's a rocky shore. Get it? Rocky, no, okay, all right. Sandy shore, okay. Muddy shore. Estuary, and a delta. All 5 of those things you have to know the difference between. When you see a picture or when you see a diagram, even if it's like hand-drawn, black and white on a test, you're going to have to know the difference between those 5 different types of, I'm going to talk about each of them right now. So, and yes, you can find sharks in estuaries. This is where my second book up there, From the Edge of the Marsh, imagine a house, a shack on stilts out here on one of these marshes. That's what that book is about. Some stories about growing up out there. So it's really cool. All right. So rocky shore, here we go, rock. And this is some of the critters I was talking about. I took this picture. These pictures I did not take. But a rocky shore obviously is a shore with waves hitting the rocks, okay? Currents, tides, they weather the rocks. There's not that much erosion because granite and igneous rocks are so resistant to weathering. Limestone a little bit more, like the pictures I showed you here in Florida. So because there's not a lot of erosion, because they're big rocks, they don't move a lot. And so because there's not a lot of erosion, there's not a lot of sedimentation also. So you can get rock tides and rock pools. Here's a rock pool, the water is up here, and in those rock pools you get critters. And this is called a polyplacophora. We're going to learn more about that. Poly means many, plaque means shells, and so you can see it's got many shells. It's a suction cup guy, and it just suction cups onto rocks. So when the waves are hitting it, it can just stay there. And it has this radula mouth. I'll teach you what a radula is in the future. And it just moves along like a cow, munching on grass, but munching on algae. Same with these guys. They're called limpets. So they have very unique habitat, a rocky shore. Now, you don't have to copy anything down here. This is just a little extra information. So it's talking about, you see how the out here where you've got more wave energy and it's moving inland, of course, but you can have a lot more erosion here than you are in here. And so here's a real example of that type of thing where you cut a notch in an arch right there. And then I believe there's more information about that stack right there, or stump. Yeah, oh, this is a different one. Okay, so here's Darwin's Arch in the Galapagos Islands. And just last year, May 16th, it was standing, and it was standing forever. Darwin saw this when he went to the Galapagos Islands. They named it after him. It was Darwin's Arch. And then the next day, the entire thing collapsed in this whole piece. Gravity was just too powerful, and it took over, and it eroded it. The weathering had been too much, so gravity eroded it, and then deposited those rocks down here at the bottom. WED, W-E-D. Okay. Marine terraces. This is when waves cut into the shoreline, and depending upon the sea level changes over thousands of years, you get these different terraces. Okay? So at one time, the waves were higher up, the sea level was higher, and it cut these away and made this terrace. Then the sea level went down, and then it cut these terraces. And then you're going to get landslides and deposits. And so here's the old sea cliff. That's the old sea cliff up there. And this is the modern sea cliff there. So these are two examples. And this happens everywhere. Hawaii, Scotland, California, all over the place. Northern shore of Long Island, marine terraces. Sandy shore, here we go. So I grew up with these guys. These are Limulus polyphemus, or the horseshoe crab. ancient creatures related to scorpions. They've been around forever, obviously, and they love sandy shores. They love to mate. This is a male and a female. The female's bigger, and then she will lay her eggs in the sand. So they have smaller waves typically than rocky shores. Gradual slope, not anything steep. Sand and sediment is constantly shifting around. Not much energy to move tiny particles, right? Waves and currents, tides, all erode sediment, more so in the winter months. The ocean is rougher in the winter because of temperature changes, changing the currents in the water. Waves, currents, tides, and wind deposit sediment, and that's more so in the summer months. And then animals burrow. In fauna is one of your words, in fauna. So the key word is in. That means they burrow in the ground, in the sand. So you're going to find clams and different kinds of species of mollusks like that. Mole crabs. Some people call them sand fleas, but they're not fleas. They're mole crabs. They're harmless. You can scoop up the sand and they try to burrow down into the sand in your hand. In fauna. Fauna means animal. Flora means plant. Fauna and flora. So in fauna are animals that live in the substrate. Mud or sand. Muddy shores. Speaking of mud, okay, so somewhat protected from waves. They're usually more inland, like where an estuary would be, where fresh water is mixing with salt water. Very little weathering erosion, formed by sedimentation. So you've got this deposition of eroded material that was carried here, typically by rivers, and deposited in these flats, okay? Very small particle size, like silt size, very low in oxygen. The sediment is very low in oxygen. So you're going to get this hydrogen sulfide stinky smell oftentimes. It's not dangerous or anything like that, but it just smells when you're around areas like that. You may smell it when you're down by the intracoastal and the mangroves when the low tide goes out. Very gradual slope. Mud flats, they're called. This is pretty much what we would see when the tide went really far out on the bay. We would see mud flats. And you will sink up to your knees, up to your waist if you stay still in one time for too long. Deltas. Deltas are these. These are called river deltas or alluvial fans. Alluvial fan is more dry, but so the river is coming out and it's just depositing sediment in this vein-like structure. So fresh water is coming into the salt water to where the river ends at the sea. And so some of the famous ones you may have heard are the Mississippi River Delta, the Nile River Delta in Egypt, and that dumps out into the Mediterranean. The Mississippi dumps out into the Gulf of Mexico. The Amazon Delta, the Mekong River Delta in Vietnam, they're all over the world. So fresh water coming out, vein-like, and pouring its sediment into the water, into the ocean, shaped by sedimentation. So an estuary, here we go, that word estuary, you've heard of it before, fresh and salt water mix, making water called brackish water. You still can't drink it, it still tastes quite salty. It would make you sick, so you can't drink it. So sheltered from weathering and erosion by the ocean. So this is going to be somewhere like in an intracoastal area where you have these barrier islands. The beaches all along the Florida coast are barrier islands, and this would be like an inlet. Then you've got this lagoon here, and the lagoon is the estuary. Okay, so but estuaries can form in 4 different ways. We are more familiar with this. Long Island is the same exact way as Florida. Same exact way as here in Boca, where you have to go over the intracoastal to get to the island, which is the beach. That's this. Long Island is the same way. But in other parts of the country, in other parts of the world, you've got this drowned river mouth. You've got a fjord, which we talked about is cut by a glacier, that U shape, right? And tectonic estuaries, where you've got shifting plates that make this happen. And we are bar-built, formed by a sandbar or a barrier island, and behind it's protected by the waves and you get this mixing of fresh and salt water, salt from the ocean, fresh from the land, and it's brackish and can have high turbidity. That's a vocabulary word you should know about in this class. Turbidity is how much stuff is floating in the water. They're also called lagoons, bays, sounds, sloughs. And this is our last slide for our notes today. These are actual pictures of, so here's Boynton Beach actually. This is my beach, I live in Boynton Beach. And this is the Boynton Beach Inlet. And it's beautiful. So when the water is coming in the inlet, it's beautiful. It looks like a fish tank. It's just amazing. Better than the Caribbean. And I was in the Caribbean last summer, and I'm telling you, this is beautiful. Tropical fish, just everything. Really good snorkeling in all four of these areas. So if you've never been, you should go there. Okay. On an incoming tide. On an outcoming tide, all this brackish, turbid water from the estuary, this is the intracoastal, this is the mainland, this is the beach, barrier beach island, okay, bar built. All of that stuff comes out here, and it makes this all turbid or silty, you know, and it really messes up everything out here as well. But when the tide shifts and then the tide starts coming in, it all changes and becomes beautiful, like a beautiful fish tank at the aquarium. Here's a fjord, U-shaped valley. This is a tectonic. Anybody know where this is? That's San Francisco. My new book that I'm writing, part of it takes place like right here in Stanford University, so it's pretty cool. And then a drowned river valley, like a delta, river delta, okay? So that is part 2 of our notes.